Hi guys, so I am going to be recording a video of myself reacting to, my math lessons. This is going to be a bit different of what I did from my previous videos because I did a reaction video of reacting to game reactions, like, from Jay's channel, Cub Scouts. And I'm trying to put a reaction of myself when I'm trying to learn, like, my new lessons for my math class, specifically from Calculus 2. And if you don't, if you want to know more about this lesson, if you're having Calculus 2 class, I'll just leave the video, the link in the description down below, so you can all check out what I'm actually learning. Because at this time right now, the whole campus, my whole college campus is on quarantine mode, so we don't actually have to go to classes over there, so we only have online classes instead. So yeah, this is gonna be reacting to stuff right over here, lesson stuff, and let's get on to it. I just have to. Ooh, too loud. Good.
So we're going to start off by discussing curves defined by parametric equations, and I'd like you to consider this example. So you may notice that this curve here, curve C, fails the vertical line test, but the x and y coordinates of the particle are functions of time now. So this is the way we're going to start describing it. So instead of just x and y coordinates, we have our f of t and our g of t.
So basically x coordinate is equal to ft, and then y coordinate is equal to gt. Makes sense visually, yeah.
And there's two really important things
and then there's identities
to remember.
Given right there. So there's the x
with parametric equations,
plus minus 2t,
now the graph
and y
tells
equals t plus 2.
When
it tells when
we are a point in time, and the graph gives a...
Oh, what? I didn't even listen to. I'm just talking shit.
So there's two really important things to remember. So
okay, two important things.
With parametric equations, now the graph tells when we are a point in time.
A point in time, okay.
And the graph gives a direction.
Okay, so I just have to pause this video real quick because I'm just actually taking notes. So after I'm done with that, I'll just continue playing.
And so we're going to start moving into this environment, and we can say that x is equal to f of t, and y is equal to g of t.
That's what I actually said.
And these are given functions, and we now have a third variable, which is t, called a parameter.
Oh, so that's
the
unknown variable, because I was just wondering, this could be another function, but it doesn't have f of x or g of x, but instead it has a different variable of t. So where is this motherfucker? Okay, there you go. Yeah. So I know I was right, but the thing is t, t, is that another way of saying x? But definitely not, so... Oh shit. No problem no more because I have an eraser. No, not this one. This one. It's way easier. Where the fuck? Oh, there you go. And let me just erase this. Yeah, there you go. Perfect.
So we simply use to describe it.
Mm-hmm.
And so at each value of t, this determines a point on the xy.
Wait, I wasn't
and these are the equations we simply use to describe it.
Yeah.
And so at each value of t, this determines a point on the xy curve.
Uh-huh.
And we can plot this using the coordinate plane. So as t varies, x and y, the point we get will vary as well. And so we'll start with a simple example here. So we've got x is equal to the function of t squared minus 2t, and y is equal to the function of t plus 2.
Yeah.
So the first thing we do to start working in this graph
Okay.
is we'll make a little table. So
Oh,
we'll
a
have
table.
t of our variables, we'll have x,
Oh, okay,
and we'll
so
have
that's what
y.
it means. I have to stop being like a
And
fuck
so
girl.
break these up too. So we'll just start. We'll just start plugging in values for t and see what comes out for x and y. So
Y.
t
Hold on,
equals
shut.
negative.
Oh, hold on. Before I do anything else, I'm writing down. I'm writing it down. Okay. I have slow handwriting. Maybe that was like the reason, like in classrooms, like if the teacher's writing so much faster, and the teacher will say like, "Are you all done?" And I'm just like this one person or other reliable person would say, "Wait, I'm not done yet." And then they just like erase it quickly. Oh man, I would hate
Negative
that.
1.
Okay, starts with a
Then we
negative
have
1.
negative 1 squared, it's just 1, minus 2 times negative 1. So 1 plus 2, so x coordinate will be 3.
Okay. I'll just
And-
have to write it down. I don't want to be solving it like right in this paper anyway, because I'm putting like also my homework in this notes too as well. It just helps. Everything is all in order and organized.
Negative 1 plus 2, so the y coordinate will be 1.
Okay.
And that is our first point, so let's find that now. So x is 3, so 1, 2, 3, y is 1 up here, and that is at t equals negative 1. And so
Okay, that makes sense. Man. Only thing is, like, this is gonna be like a lot of work once you try to graph from this lesson right over here. I just don't like a lot of work, but you know, it's really fun when you do the work, but there's like a whole thing like you like to do. It's like a jumble of like puzzle things that you have to solve, which is really fun. Like some of you do like math, and some of you, or maybe like mostly people, doesn't even like math.
So we're just gonna keep doing this. So negative 1, now we're gonna have t is 0.
T is 0.
So
Okay,
at
got
t
you.
0,
I got you, fam.
we have x is 0, so
Yeah.
0 squared minus 2
It's all
times
0, yeah.
And we
And the other
have
one for y is
is
2.
equal to 2.
Yeah.
So this is our next point now. We have x 0,
0,
y is 2.
2.
And we're just going to get a few more. So at t is 1,
This is
we have 1 squared minus 2. So we've
another
got
one. It's gonna be 1.
negative 1 for the x coordinate. 1
Okay.
squared minus 2 times
Alright,
1.
I got you, fam.
And we have 1 plus 2, so we have 3 for the y coordinate.
Wait, what?
So
I didn't
negative
even listen. Oh, yeah.
1
Right.
and 3.
Alright.
So
Okay, so that's gonna be. Come on.
t equals 0.
Uh-huh.
And this is at t equals 1. And let's get another few points here just so you can start seeing this curve come.
Yeah, the only thing that I like to do when I actually put down like a graph, I only put like three points in. Just like for t, like negative 1, 0, and 1, because it's like this symmetric dynamic thing like I got myself into like graphing into graph something, like if I'm actually trying to solve something or actually look the identification of what the equation is. Like for example, like if I'm just going to be doing like y equals x squared, that's like an easy part, or like y equals x to the cube power. I mean, that was just pretty easy, and I do this like basic things where I find like exponent points and plug in where 0 is or 1 is. I mean, that part of like plugging in stuff into a table right over there, I mean, that's really fun. But like, it's no fun that you add in like more points. Unless you want to make it like more symmetric. Like, for example, because you add in like 2, what about the negative 2? Where's gonna be the negative 2 at? Come on. Ain't no fair. Ain't no fair. Ain't no fair for me. Like some people will think that too. There ain't fair for them too. I mean, jeez. Save the symmetric table to us.
Come to life. So 2 squared is 4.
Yeah.
Minus
4, that's going to be a 0.
2 times 2. So 4 minus 4,
Yep.
so x is 0.
Yep. I don't have to tell you
2
twice.
plus 2, y is now 4. So
Yep.
1, 2, or
0
1, 2,
and
3,
4.
4. So it's going to start
1,
heading
2,
back to the
3.
right. T equals 2. And let's just do one more. So 3. So 3 squared is 9. minus 2 times 3, so
That's
6,
gonna
so
be 3.
9 minus 6. X is 3,
Yep.
and
Okay, that's gonna be
3
5.
plus 2, Y is
So
going to
that's
be
gonna
5.
be 1,
So
1, 2, 3,
X
4,
is 1,
5.
2, 3.
Oh, what the fuck?
Y is 1,
1,
2, 3,
2.
4, 5.
Oh, hold on. You talking too much. Like, damn boy, come the fuck down. 3, 1, 2, 3, 4, 5. There you go.
So
Where t equals
somewhere about up here at
t
t
equals 3.
equals 3. So we've now got our curve, and we can start filling it in. I'll try to trace this as best I can.
That's a
And
nice
so
trace.
now we
That's a
notice
lovely
that
trace. I love that trace. Oh my gosh, it is. Oh my gosh, it's so symmetric. It's like a parabola curve, but sideways. I forgot what that one was called anyway. Like identity of the curve. Whatever, man.
this
Alright,
actually has a direction
parabola.
to it. So the direction
Something.
is heading left.
I think I'm right.
And then it turns around, and we've got a...
Turns around, then it comes around.
and then it turns,
Yeah.
and we head to the right.
Yeah, don't forget like the arrow
And
parts.
this is our
You
curve.
know, I really
so,
need that shit.
so this
Looks
is the
so
environment
beautiful,
where
so
we're just going
lovely.
to start working
I love that
in.
arrow.
And you can notice from this that the particle, in this case, traces out a parabola.
Yeah.
And this can actually be confirmed if we eliminate the parameter t.
Wait, eliminate the parameter t, and it's already done? What kind of shit is this? I need a continuation. Oh, parametric curves basic graphing. Do I really want this? I don't know, man. Wait, what's this? Parametric equations, introduction, eliminating the what? I can't even read shit. Eliminating the parameter t and graphing plane curves. This one is definitely like organic chemistry tutor. I think it's the same thing like with Khan Academy. You know what? Either this one or this one. This one's 8 minutes long. This one's 33 minutes long. God damn! I'll definitely put this one on. And I'll also give that link right in the description.
My textbook only lets me...
Cool. I became
All
so
right,
squarish.
in this video, we're going to talk about parametric curves.
Curves,
And
yeah, okay.
one thing that parametric curves are good for are describing curves in the plane that
Shit, you don't have
aren't
to tell me
necessarily
twice.
functions. So if your graph is y equals f of x, maybe y equals sine x or something like that,
Oh, it's
you'll
been
get a
long time
nice
since I,
graph that's a
grafting
function.
to, like,
But
curves
the
from
idea is
sine
here
and
what we're going to
cosine.
do is we're going to
Shit.
make our x-coordinate a function of a new variable. We'll call, they usually denote it as t.
Oh, yeah.
And then the y-coordinate will also be a function
Okay,
of
so
t.
I have to skip this one.
And I'm going to move parametric curves.
Oh, yeah, that's a lot of curves right there. That's some messed up shit curves.
Curve x equals 1 plus...
Oh, okay.
So suppose we want to graph the parametric curve x equals 1 plus square root of t.
Okay, so
y
this
equals
is like
t
a
squared
perfect
minus
example.
4t, and then t
But
is
not
between
exactly
0
because I already did
and
the
5.
example, which I really solved for the graph, and it's already like, sketched out at its way. Maybe like another example.
Just like when
Might
you
be.
normally make a t-chart, sometimes what are called t-charts,
Okay, so because the first one that I did, that's going to be just like my first example. Example number 1. Thank you very much, my good man.
that's what
Did
we're
I
going to
say
do
man?
here though. Instead of
What the
making
fuck?
x and y though, we're actually going to we'll pick a value for t, and then we'll pick a value, once we pick a value for t, we'll be able to calculate x.
Okay, so two like examples, the same thing, but it's a different way of showing it from the function itself. And I see how it goes already. So like when you use something for t, like for the variables, I guess I have to think of the negative x coordinates, like right from the side to like symmetric thing that I like to think of, and plugging it for like x and y for the x function right over there, which is f of t, and the other one is the y variable that equals to the g of t. So I think I'm all good. That's a bit much, and you saw that I had like a long ass like note taking time because like I just paused it, and you're just like wondering, okay, so when are you gonna be done taking notes? I'm just like one of those people that likes to make things so nice and looks good. So like if I do have like one of those I do have some of my notes down, but they're all messy, and then I rewrite my notes again just to make it look nice. But this one here is so one right through just to make it all look nice. That's all what I have to do, because I mean, what's the fun in that if you want to make your notes look neat? Because you want to be so organized with all of your lessons that you have to learn to. And I just want to ask you guys and comment down below, do you also have like neat handwriting the same as me? Or if not, are your handwritings like really messy? I'll just read down in the comments below and see what you actually said. And thank you guys so much for watching, and